Okay, good morning, afternoon, or evening, everybody. Welcome to the Let It Snow, Accessing and Analyzing Snow Data at the NSIDC DAAC Earthdata webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. First, what I'd like to do is go over a few webinar logistics. To ensure the best audio experience, participants have been placed in silent mode, but if you have any issues or you have any questions, please enter them into the Q&A pod, and you'll find that located on the right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog as well as to our Earthdata YouTube channel within a few days of completion. Once completed, what I'll do is I'll send an email to all of the registrants with both the direct recording link as well as the YouTube recording link. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations and an additional 15 minutes for the question and answer period. Our speakers for today are Dr. Walter Meyer, who is the National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC scientist. He will begin today's webinar with an introduction to the NSIDC DAAC and the snow data holdings that are available there. From there, we will transition to our second speaker, Amy Steiker. She is the Data Services Lead at NSIDC DAAC. She will present several live data discovery and data access demonstrations, including a Jupyter Notebook use case. After our speakers have finished with their presentations, we will move to a final optional set of polling questions. Generally, what I'll do is I'll give these questions 3 to 4 minutes or so, and then from there we will transition directly to the Q&A period. Depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, but we will have a hard cutoff at 3:15 p.m. Eastern. With that, it is my pleasure to introduce today's first speaker, Dr. Walter Meyer. Dr. Meyer?
All right, thank you, Jennifer, for the introduction. As Jennifer mentioned, I'm going to start off with a brief introduction of the NSIDC DAAC and the snow products that we have there. And first, for those that may not be familiar with the DAAC or NSIDC, the DAAC at NSIDC, we're one of 12 DAACs within the NASA Earth Observing System, Data Information System project. There's 12 distributed around the country, and our focus is on snow and ice and the snow and ice products. Currently, we have over 500 products and a total volume of about 650 terabytes. That's actually probably out of date by this point because our archive is growing quite rapidly now, about 300 terabytes per year. And our primary mission is, some of our primary missions is passive microwave products from various, several different passive microwave sensors, the NASA Soil Moisture Active Passive mission, which is continuing to operate, and several laser altimetry products from ICESat, and then the follow-on ICESat-2, which was launched in 2018 and still operating, and then the airborne mission Operation IceBridge. In addition, we have several MEASURES products. For those that aren't familiar with MEASURES, these are essentially earth science data records or climate data record, long-term climate products produced from a variety of sensors for different geophysical parameters. And then now focusing specifically on snow-related missions and products, we have visible and infrared snow and ice products, primarily from the MODIS and VIIRS suite of sensors, and I'll talk more about these in subsequent slides. Then we also have passive microwave data, particularly from the Advanced Microwave Scanning Radiometer, AMSR, which has been operating on 2 different platforms, the NASA Aqua platform and currently on the JAXA Shizuku or GCOM-W platform. A couple MEASURES snow products, and then a couple specific field missions, airborne and field missions, SnowEx and the Airborne Snow Observatory. Before getting into the specific products, I want to quickly mention another snow feature that we have that's brand new, just within the last month or so, called Snow Today. And this isn't a DAAC-supported project specifically, although DAAC data is used as a resource. But it's funded through the NASA Hydrological Sciences program, and it's a nice quick look. We have a lot of updated imagery and analyses of snow focused in the western U.S., and then monthly or so, roughly monthly, detailed analyses of conditions during the winter period in the northern hemisphere. So if you're interested in snow conditions and kind of just getting a good overview, particularly focused in the western U.S., Snow Today is a nice resource to look at. So I'd recommend checking that out if you're interested in snow. So now moving on specifically to the products. First I'll go through the MODIS and VIIRS products. These are visible infrared, looking at using reflectance and thermal imagery to get snow and ice products as well. So for MODIS, it's been operating on the Terra and Aqua platforms and continues to operate. So we have now about a 20-year record of data, and those are in swath daily formats, 500-meter resolution, and then lower resolution daily and 8-day composites, about 5-kilometer, 0.05 degree resolution. And VIIRS is a follow-on from MODIS, essentially. Even though MODIS is still operating, VIIRS is seen as the longer-term kind of operational follow-on, which is on the Suomi NPP, National Polar Orbiting Partnership satellite, and then now also NOAA 20. That's been operating since about 2012, and it has swath and daily products from 375-meter resolution. And there are a lot of different products from these, and there are some at other DAACs, specifically at the NSIDC DAAC. We are archiving and distributing snow cover and snow albedo, as well as ice products from NSIDC. So there are other products at other DAACs. And moving on, passive microwave, the advanced scanning microwave radiometer. As I mentioned, there's two of those. There's the Aqua AMSR E on the NASA EOS series of platforms that operated from 2002 until October of 2011. And then there is the AMSR 2, a successor, very similar instrument that was launched on the JAXA GCOM or Shizuku platform. And that was launched in July, or data started in July 2012, and it's continuing. And from passive microwave, the typical sensor or typical retrieval that you get for snow is snow water equivalent. Most people may be familiar with that, but if not, it's looking at the liquid water within the snowpack. So it's giving you a sense of the volume of the snow, and to some extent the depth of the snow if you know the density of the snowpack. And so that's a common parameter to get from passive microwave. Another product that we have is a near real-time product, kind of quasi-operational. The DAACs in general, and we in general, are not an operational center per se in terms of 24/7 support, but we put this product out, regular daily product, 24-hour product, and it's meant for potential operational uses for other input for other processing or modeling and so forth. And as an operational product, it's not necessarily consistent over time. It changes in sensors have occurred, like changes in algorithms, so it's not good for a long-term time series, but it gives a good sense of where the snow extent is at fairly coarse resolution, 25 kilometers, but it's a global complete product, so it's useful in that sense. Then going from kind of the operational to the really long-term, we have a couple measures products, as I mentioned, at Northern Hemisphere snow. These are actually based on a variety of sources, particularly NOAA snow charts that started back in 1966. So this is one of the longest climate records that we have in terms of snow, in terms of at least hemispheric snow cover. So there's a 100-kilometer product that goes all the way back to 1966. And then there's a more recent product starting in 1999 that's 25 kilometer. And it uses a variety, like the different sources, satellite imagery and so forth. MODIS is a key input nowadays. And this MEASURES product ended, unfortunately. It's no longer supported, so the data ends in 2012. But it is a good long time series for folks that are looking for that. And I'll note that there is the NOAA IMS, or Interactive Multi-Sensor Snow and Ice Mapping System, produces regular charts of snow. And the Rutgers Snow Lab, also University of Rutgers in New Jersey, also has some nice graphics that are updated regularly on snow conditions. And so users can get updated information since 2012 from those sources. And just kind of to quickly summarize in terms of satellite missions, these satellite missions all have some good capabilities for certain aspects, but also limitations. For MODIS and VIIRS, you get pretty good spatial resolution, like I said, 375 meter resolution at times for swath data, 5 kilometers for daily data. But there's a lot of limitations, for visible imagery. Clouds, darkness limit your retrieval, so you don't get complete daily coverage. You're only getting snow coverage, so there's no sense of snow volume or snow depth from that. And so that's a limitation there. From the passive microwave it doesn't get, the channels that are used does not get much emission from the atmosphere in general. So it's all sky capability, and you're measuring the Earth's emitted energy from the Earth in the microwave frequencies. So it's not dependent on sunlight. So you get all sky capability, and it's polar orbiting and fairly wide swaths. So you get near complete daily coverage. As you get farther towards the equator, you start getting gaps daily, but you can fill those in over a 2 or 3 days. And as you get closer to the poles, you get pretty much complete daily coverage. But the limitations there are, low spatial resolution. It also has limited sensitivity in certain snow water equivalent levels, particularly on the low range and at the high range. And it has difficulty in forest regions because the vegetation in forests inhibit the retrievals. And then the MEASURES climatology, the big advantage of those is the long historical record, but you're getting varying quality spatial resolution, and it does end in 2012. So there's really a need for further improvements in these satellite products and better understanding of snow processes and the radiometric properties of different types of snow. And there's really a lot of untapped potential from using a broader range and combinations of remote sensing capabilities like radar and LiDAR, along with the visible infrared, passive microwave. And that's where these next projects are kind of really trying to hit. And the first one is SnowEx, which is a pretty large scale, it's about a 5-year program of field and airborne campaigns supported by the NASA Hydrological Sciences program. And the focus on this is it's developing and testing algorithms for snow water equivalent and other snow properties from multi-sensor instruments, kind of bring in more than just one sensor and looking for the best combinations of sensors that can give us the best information of snow and SWE in particular. And then also a modeling aspect to better develop and test energy balance and snow distribution models, and then combining the data and the models together through data assimilation to get the better overall snow information. And there's been a couple field campaigns so far. The first one was in February of 2017, and the second one was just completed this past winter, in January to March in 2020, with focus primarily on Grand Mesa, Colorado, which is out in the western slope of Colorado, and towards the western border of Colorado, and so that's been completed, and there'll be more campaigns in the future in the coming years. And the data that's come from them, there's a ground segment and there's also an airborne segment. The airborne has SAR instruments, passive and active microwave, thermal infrared, LiDAR, so a nice full suite of different instruments. And then comprehensive ground measurements, snow pits, snow depth measurements, temperature profiles, as well as on-the-ground remote sensing instruments, passive microwave, IR, radar, as well as ground-based drones. So there's been a lot of data collected. The 2017 data is available through the NSIDC DAAC website, and the 2020 data, of course, has just been collected, but we hope that that will be available later this year. The next one is the Airborne Snow Observatory. This is a NASA JPL-led airborne mission. The objectives are some ways similar to the SnowEx, but focused particularly on mountain watersheds and mountain water resources, getting really better fine-scale detail on specific mountain watersheds to improve the knowledge in these watersheds and provide inputs to water management systems. And so a particular focus has been, for example, on the Sierra Nevadas in California and helping out on water resources there. And it's also been contributing to SnowEx. There were ASO flights over SnowEx. And so that data will also be available as well. ASO is transitioning to commercial. And so the future of the data distribution is still TBD, but any data collected for SnowEx will be distributed through the SnowEx website. And with that, a very brief and quick overview of the snow data products at the NSIDC DAAC. I'm going to turn it over to Amy, who's going to give you a demo and an overview of data access and how to access all the snow products that we have at the NSIDC DAAC. So thanks. Off to you, Amy.
All right. Thank you for that introduction, Walt. So that was a great intro to kind of some of the background and key objectives on these new snow-related missions and some missions that we've had for quite some time. So we're now going to move on to a demo of the resources available through the NSIDC DAAC. So you may be thinking to yourself, how can I get started actually exploring and getting my hands on these snow measurements across these different missions and instruments? So we're going to start with an overview of the available materials on the NSIDC website, including some of the support and access resources available for every data set that we archive, and then also show a few discovery access and visualization tools. Now, because the snow data we're focusing on today are collected from a variety of instruments and platforms across in situ, airborne, and satellite scales, as Walt introduced, the use case we'll be working through today addresses this need to discover coincident data and compare those data values across these different data sets. I'm going to move on over now and start sharing my screen, and I'll start with the demo portion. Give me 1 second to get that loaded up. All right, you should be seeing my screen now, and we are on the NSIDC.org homepage. So I'm going to be starting there. That's NSIDC.org. And we have a few featured items scrolling through the top of the page. And I'll go back to the first one, which you may have just seen. That's our Snow Today feature that Walt already introduced. We will revisit this briefly after taking a look at the data products that we'll be exploring in more detail. So we'll come back to that. Now, obviously, we're interested in snow data today. So under the scientific data for research, there's a snow icon on the left, and that's going to jump us directly into NSIDC search. So we can find all data sets related to various snow parameters sorted by relevance by default. Now, the National Snow and Ice Data Center includes data beyond the NASA DAAC, and I encourage you to explore other data offerings provided by NOAA and our other partners, but of course we'll be focusing on our DAAC offerings today. So since Walt kind of finished up talking about SnowEx and ASO, I'm actually going to just change my search and look for SnowEx data. And in particular, I can filter by various parameters of interest, and I picked snow depth. That's one variable that we'll be focusing on in more detail today. So I'm going to select the second option here, which is the SnowEx 17 ground penetrating radar data set. And this is going to take us to the data set landing page. So every single data set provided by NSIDC has a kind of data set homepage or landing page. And this is really your one-stop shop for information and access to the data. And if you happen to attend the webinar that we provided through the NASA Earthdata webinar series on ISAT-2 this past summer, we gave a similar overview, but I will share this again briefly since we have a lot of helpful information here. So at the far right of sort of this tab section below the summary, we do have a level of service icon, and we have a level of service associated with every single data set that we provide. That's that icon in green here. So for this data set in particular, we have a standard level of service, and this, our levels of service range from basic to standard to comprehensive. But in this case, for SnowEx, we provide a standard level of support of this data set, including data integrity verification, documentation, curated user guide, user support, as far as accessing and working with the data. Have a nice summary there. Now, as Walt mentioned, we only have the 2017 campaign data available currently, but we will be expecting 2020 data, hopefully later on in the year. So I want to point out this mailing list option at the top right of every landing page. And this gives you the ability to sign up for our mailing list. So in this case, you'll receive notifications and updates for SnowEx data. So I encourage you to sign up there or on any other dataset landing page that's of interest to you, and you'll get notified of new data or any notifications that are of interest to the community. So just to go over the information provided here quickly, on the Overview tab includes key parameters, including file format and coverage. You can see that this data set in particular is available as a CSV. I'll come back to the Download Data tab in just a moment, but we also provide data citation information. We have a user guide with info on how the data are structured and organized and how they were generated. I'll actually move down to the data acquisition and processing just to kind of give you a background here. So this snow depth data set, this was derived using a ground penetrating radar, and the data were collected along individual transects with SnowEx scientists pulling the radar unit in a sled across the snow. So I'll actually visualize this data in just a moment. So I'll go back up, scroll all the way to the top here. We also have a technical references tab. If technical references exist for data sets, they don't in this particular case. And then last but not least, we have a support tab, which contains how-to guides and frequently asked questions about the data if available. So in this case, we have 3 how-to articles here, and 2 of them are really focused on accessing the data, both programmatically using our API and through our Download Data tab. And then we also have a new article that I'll come back to later that points to our tutorials repository on GitHub, particularly for this use case that we'll actually be working with today. So we'll move over to data access, and I'm going to now go over to our Download Data tab. So on the left, I'm presented with a map, and I can see, if I zoom in a little bit, I could see that the coverage of the entire data set is kind of highlighted in this green-blue box that you can see, again, over that Grand Mesa study site over the western slope of Colorado. And then I can also see the temporal coverage at the top as well. Now, if I want to drill down a little bit further and explore some sort of spatial discovery resources available on the map, I can click this little polygon symbol at the top right of the map, which will allow me to draw a polygon. And you'll see in a minute why I'm just kind of tracing the coverage that already exists. I can complete my polygon there, and it'll kind of filter, which, we have the same number of files that we saw earlier. There's just 3 files that are associated with this data set that you could see on the listing on the right side. And there's a new feature here that allows you to save that polygon as a GeoJSON file. I can do that by clicking the Save button here. That's going to automatically download that. And we'll actually use that in our next exploration. I just wanted to point that out for now. So as far as downloading the data, if you're interested in getting everything here, we have a couple of options. We have a download script, and that will provide a Python script that you can use. We also have an order files option, and that will provide the data back as a zipped file of all the data that you're interested in. And then there's also this large or custom order option. And it doesn't apply to us in this case, since this is a pretty small data set. We just have 3 files here. That will take you to Earthdata Search, though, with your spatial and temporal filters preserved. So while this is a great option, a really easy option, kind of keep you in one place to get the data that you need, and it's great for an individual data set, we're interested in finding coincident data over the same space and time. So our next task is kind of search and access other snow data that coincide with the same region. And we'll be focusing on this Grand Mesa study site from here on out. And so we can use NASA Earthdata Search to do that for us. And under our other access options, We do have an Earthdata search option here, and that will launch you directly into Earthdata search into the data set that you came from on NSIDC's site. So I'm actually going to move over now to Earthdata search. And just for demo purposes, this is basically what it'll look like once you get landed into Earthdata search here. And for demo purposes, I've actually already uploaded a temporal temporal range of interest by clicking on this calendar icon under the search bar here. I'll zoom in a little bit if that's a little small for your screen. Now I'm keeping our temporal coverage very broad for now. So let's say I'm just interested in the entire year of 2017. So that's what I've set for now. And now I'm going to move over to the map. And if you're familiar with Earthdata search, but maybe haven't been on the site recently, we do have a new vertical panel layout, which is a really nice feature. You can actually completely collapse this if you just kind of want to explore on the map in a little bit more detail. And now I can go ahead and upload the same polygon that I just downloaded, that I had drawn on the SnowEx dataset landing page. And I can actually just go ahead and drag that file into the Earthdata search interface. If I zoom in a little bit, I could see that that polygon is now kind of highlighted in that blue-green outline. So we can see that that's kind of entered in, and you can do this for KML or shapefile, so any other feature shape that you already have on hand. If you're interested in another region, you can just drag that into Earthdata search. Another thing I want to point out that's a newer feature next to the spatial icon, again under the main search bar, is this advanced search feature. And this is where you can search by U.S. Geological Survey hydrologic unit codes, or HUC IDs. So this may be of interest to the snow hydrologists joining today who may kind of use these codes or use these watershed boundaries in your research application. So that's just another yet another feature, way to kind of search by area of interest. So I'll close that out. Now if I want to explore multiple data sets, going back to the panel, I can add this data set to my project by clicking the project button next to the download all button. And I can continue to add data sets using the same filter, and then I can click on this My Project button at the top right of the page after I add more data sets. Now I already have a project preloaded with 2 other data sets that I'm interested in looking at today. So beyond the SnowEx data set, we're also going to be looking at the Airborne Snow Observatory Level 4 LiDAR snow depth data set. This is a very high resolution 3-meter gridded data set. So we'll kind of be looking at that next tier, as far as geospatial scale, looking at airborne data. And also we'll be looking at MODIS snow cover daily data. So I kind of have that project kind of preloaded, and there's multiple ways to access the data from here. You can get this directly downloaded, also receive a script or get the data staged for delivery. And for MODIS, I'll point out that we do have additional customization options. I'll show these in a little bit more detail in a moment, but we do have the ability to format the data to GeoTIFF, for example. We can reproject and subset by time and by variable. And I'll come back to that in just a minute. So I'll kind of end the Earthdata search exploration there. And I kind of want to point out that this tool provides you kind of with all the data that exists over that time and area that we filtered. We could see there's actually quite a few files here, and it's quite a lot of data, over 11 gigabytes of data. And the coverage, though, does not necessarily overlap the same time. And we can kind of see that in the timeline below. We see much more consistent data from MODIS, as Walt mentioned. This is, it's a daily product. We do have some gaps in coverage, but it's pretty consistent. But we have, not as consistent coverage for our airborne or our in situ data. So let's now move over to a Jupyter notebook that we've crafted for this case. This is where we'll now explore kind of coincident data across these data sets. So I'm going to go back to the dataset landing page that we were just on, and now focus on that third help article that we have here for how to search, access, and visualize snow data using Python. And there's a link here to our NSIDC data tutorials repository. So I'll move over to that now. And we should be also including the link to this repository in the Adobe Connect window if you want to follow along and kind of take a look at this repository on your own. So if you're not familiar with Jupyter notebooks, they contain a mix of markdown text and code blocks And they support, several programming languages, but we'll be working on Python code today. And this repository houses this tutorial as well as previous code-based tutorials exploring NSIDC DAAC data. So the README, if I scroll down a little bit, provides a summary of what's available here. And if you're following along, you can click on this Launch Binder button right under the title of the README. And what this does is it allows you to open a notebook in an executable environment that's already been configured for you. You can run it within your web browser without needing to set up anything locally. But we also have instructions kind of scrolling further down on how to use this and how to run these notebooks using Docker, a Docker image, as well as locally with Conda as well. So we have a couple of options for you. And if you click on that binder icon, it might take just a few minutes to load up. And I do actually already have this preloaded, ready to go. So this is basically what the kind of Jupyter Lab interface, what it will look like once you kind of have this loaded up, depending on what option you chose. And you'll be dropped into a Jupyter Lab interface, like I have up on my screen. So if you're new to Jupyter Lab, it's a web-based interface that allows you to work with documents like Jupyter Notebooks, but it can also include terminal windows and other components. So you'll see a data, sort of a directory structure on your left, and I'm going to go ahead and navigate over. I'm in the Notebooks folder already, and I'm going to navigate over to the SnowEx ASO Modis Snow tutorial that I'll be looking at. And then I can click on the Snow tutorial Jupyter Notebook to get us started here. Now note that we also have a rendered notebook, which is already kind of has the code outputs printed out as sort of a cheat sheet. So I'll get that kind of loaded up, and we'll kind of move now into the notebook. So this provides links to resources on our Snow products, many of which Walt has already covered today. And then we'll walk through how to find coincident data across data sets varying by scale. We'll read those in, extract our gridded values at point locations, plot up those values, and then get them into a form that can be used for further GIS analysis. So, although we're working with 3 specific data sets today, these functions and operations can be modified to suit your needs depending on the data set format and structure that you're interested in. And although we're providing this in Python, we certainly understand that this may not be your, the most common language that you're, or maybe the language that you're interested in working with. So I hope this basic workflow and kind of example code could provide a foundation that maybe you could apply elsewhere. And we're certainly interested in your feedback. Have some questions at the end of this webinar as far as what other resources we can provide. So definitely looking for feedback on that. So we already mentioned Snow today earlier, so I'm going to start scrolling down to our Snow products and resources section, a lot of which I already kind of walked through. And moving over to Snow today, a little bigger in case small screen for you guys. I will go ahead and click on Snow today and just show this in a little bit more detail. So as Walt already presented, this gives a nice high-level summary and also daily plots of snow conditions, particularly across the western United States. And if I scroll down past the images provided here, this was our April edition, so it's talking about the March snow cover and snow conditions. And just to kind of give a summary of that, we saw just below average snow cover in the western U.S. in March and saw some variability across the region with areas both above and below average cover. So we may want to look at monitoring stations, like the Grand Mesa study site to more closely examine snow depths and snow water equivalent, snow cover as well during storms and melt events to better predict behavior and meltwater. So kind of one sort of use case. Moving back over to the notebook, I'll scroll down and now focus on the data discovery. But I do want to mention that we have some links here to the data sets that we're working with today, and I kind of provided some data set search links for other relevant Snow products, again, some of which Walt had already mentioned. So I'm going to start by importing my packages that I'll need for the next few code blocks here, and I'll move on to data discovery. So that same Earthdata project that I showed earlier is listed here. And again, the same steps I showed earlier to identify an area of interest and export a polygon are also shown. So again, if you have any other spatial area of interest, you can use that below. So we're going to now create a polygon coordinate string, and I've actually provided in the repository, I have that same polygon that I drew that I showed earlier. And we're now just getting that into a form that we can now search against programmatically. So we have that loaded up, and I'm going to set my time range. Again, just setting this broad to the entire year of 2017, just like I did in Earthdata Search. And now I'm going to create a data dictionary with the 3 data sets that we're interested in with our identical parameters. And I'm using a dataset short name and version to identify these data sets. And these short names are kind of dataset IDs or kind of codes. Those are available. You can find those at the top of every dataset landing page. They're just above the kind of long title. You can get those as well as the version from our dataset landing pages that I already showed. So now we can determine how many files exist over that time and area of interest. And this is basically going to provide us with the same information that we already saw through Earthdata Search. So we have quite a few files, particularly of MODIS. Basically, we have a day of data for the entire year. We can see that, as well as, like we saw in Earthdata Search, there's quite a lot of data, several gigabytes worth of data. So this next step, though, is now actually trying to find coincident data. So we want to go a step further and determine what time ranges are coincident based on our polygon, that bounding box. So we have this helper function that returns a data frame with the file names, dataset ID, start and end date. And we can see now that only now 19 total files are returned. So we've really reduced that data volume quite a bit. So we can see our 3 SnowEx data sets, which are kind of the limiting factor here as far as finding coincident data. We have our ASO, LiDAR snow depth data. We could also see those time ranges here. And then just the MODIS daily data that also are coincident over time. So we have that kind of pulled into a data frame now. And now we can pull the data access URLs that we could then use to actually access the data or download the data. So this next kind of step here is querying the common metadata repository. And the common metadata repository was used in the above steps as well. The powerful metadata repository that kind of houses all metadata that we have for our data files and data sets to get all this information. So now we can get this listing, and this provides both the science files, so we can see our SnowEx.csv files and .xml for our associated metadata files. And we also have some associated quality files with the Airborne Snow Observatory data. So I want to point those out just for the demo today. I'm not going to be working with those or filtering by those quality quality files, but those do exist. Beyond just those direct kind of data access URLs, I do want to point out our additional API access point. So data can be accessed directly from our file system, as I just showed, but we do also have an API, and that offers you the ability to access data based on spatial and temporal filters. And for some data sets that have additional subsetting, reformatting, or reprojection services, you can also access those programmatically through our API as well, similar to how you can do this through a web application like we showed with Earthdata Search. So for MODIS data, we have some resources on our MODIS Mod 10A1 snow cover landing page for what services we have available. And for MODIS, for Mod 10A1, we are interested in the geotiff reformatting capability as well as subsetting. So the ASO data, these are also provided as geotiff. So we just want to reformat to geotiff so we can get these gridded data sets in the same format kind of ready to go. So this next step is kind of just setting up our API endpoint. You can kind of see what that looks like. We're requesting a subset using the polygon bounds that we had above. So we'll kind of add those into our MODIS dictionary. And now we can create an API endpoint. This is kind of what our API looks like, where it's querying the data set that we're interested in, the search parameters that we've used above, like based on our polygon and time, as well as the subsetting options and reformatting options. So now we have a few download options. We can grab those URLs that I showed earlier, as well as access our API requests directly in Python. And for demonstration purposes, I've actually commented a lot of this out. I'm sort of doing this cooking show style and have the data files that we'll be using below already staged. But if you are following along in Binder, we do have, for this demonstration, we've also already staged these data on a stage directory that you can just pull from sort of for ease or for convenience. So just make sure to uncomment these if you are interested in exploring this in more detail. And I'll note too that if you're working in Binder, there's only kind of a certain memory limit that Binder has. So because these ASO files are quite large, I definitely recommend using either the Docker or Conda options if you actually do want to download all these data. So again, I already have that kind of preloaded and ready to go. So now I'll start to actually read in the files. So I'll start by reading in the SnowEx data. Again, those are provided as CSV, and I can pull those in as a pandas data frame. And I can see the different parameters that we have here. This thickness variable is what's of interest to us. This is our snow depth variable. We can see that provided in meters. And I'm now going to convert to time values. So we have to extract one of these, this collection variable, to actually pull out the time of interest. And I'm going to kind of keep reducing the data volume as I go here. So now I'm just going to pull out a single day. We'll start with just the February 8th. This was the first earliest data collection date. And I'm just going to subset that down even further just so that I get the February 8th data. And I'm now going to convert that to a GeoPandas data frame. This provides the necessary geometry that could then be used for further geospatial operations. So I've set that up. Now, an additional feature that I just wanted to show for further data reduction capabilities, as you saw with Snow Today kind of looks at lots of NASA data that's available, and it will kind of focus in on snow teleregions as well. So I know, again, for the snow hydrology community, you may be interested in SnowTel site locations. These are not provided by us. These are provided through the USDA Natural Resource Conservation Services, but let's just say for our demonstration today that we're interested in a site, a SnowTel site that's near where the SnowEx data at the Grand Mesa study site were collected. So we just want to pick that and kind of create a buffer around that site. So we just kind of want to further reduce the data around a 500-meter buffer, perhaps to compare with SnowTel data. So we're kind of done and ready with our SnowEx data. We'll now read in the Airborne Snow Observatory data, and we'll also kind of clip that to our buffer. So these snow depth data from the ASO LiDAR snow depth 3 meter UTM data set, these were calculated from surface elevations measured by the Regal LMS Q1560 airborne laser scanner. All this information is provided in our user guides if you want more information on the data acquisition. And these data are provided as GeoTIFF, as I mentioned earlier. We're going to use the raster IO library to read in the data. And then, like I mentioned, we'll kind of clip the data to our SnowTel buffer, just to reduce the data volume and kind of get all those data sort of coincident over that area. So we're kind of set on our ASO. And finally, we'll read in our MODIS snow cover data. And we're working with what we're interested in today, and this parameter was recently available with the new collection 6, version 6 data. This is the normalized difference snow index parameter. And this is an index that's related to the presence of snow in each pixel. So we have some additional information in our user guide and even additional information in a frequently asked question that I linked here to talk about what how NDSI is derived and kind of what this means. So that's the parameter that we're interested in. We pulled that in, and again, that was collected and subsetted already through our API service. And now we're going to add these points to our MODIS and ASO points to our GeoPandas data frame. So we're going to set our SnowEx geometry. We have to define some geometry parameters for these. So I pulled in the SnowEx geometry, and we can look using the GeoTIFF metadata. We can get some information on the bounds and the projection information to kind of set our area definitions that we'll use in the next step. So I've created those, set up for all 3 of our data sets, and we're now going to interpolate the ASO and MODIS values onto our SnowEx points. We're using the PyRE sample library. And so now we will add, basically finding every raster value that corresponds to each SnowEx point, and we'll add that to our geo data frame. So you could see, this is our thickness variable that we already saw through SnowEx, and now we've added our ASO snow depth, also provided in meters, and we can already kind of start to compare the ASO snow depth data to what was collected on the ground in situ. And we can see just from a quick glance, these are just these are very close, within a couple of centimeters of each other. And of course, you could do further analysis to look at how those data compare. And then we've also pulled in that normalized difference snow index, these values as well. Much higher, or sorry, coarser resolution for the MODIS data. These are already at 500-meter resolution. We'll see what that looks like in the next few steps. So now we'll visualize the data, both in Python, and sort of get this into a form that we can use for further GIS analysis. So we're going to start by plotting the buffered ASO data. So that's this high-resolution 3-meter data set. And we've plotted our SnowEx transects. You can see kind of how the transects work with SnowEx and where those snow depth locations exist, plotted over our ASO data. And we can do the same for MODIS. Again, this is a much coarser data set, and this was subsetted to that entire Grand Mesa region. So the snow depth values, SnowEx are a lot smaller here, but that's just at a high level, kind of what the data look like. And we can kind of move into our next few steps here for visualizing the data and for doing some further GIS analysis. So one more feature, one more tool that I do want to point out. We have additional data imagery services available for MODIS, as well as many other of our NSIDC DAAC data. So NASA's Worldview, if you're not already familiar with it, I highly encourage you to check it out. It's a great mapping application, provides hundreds of satellite, high-resolution satellite imagery layers, and you can get the underlying data downloaded as well. And according to the Mod 10A1 landing page, we do have snow cover imagery layers that are available through NASA Worldview. And I have a link that's already kind of set up with that layer over our time and area of interest. So this is kind of what that looks like in Worldview. This is quite zoomed out, but you can see that high resolution imagery layer here in Worldview. And using the snapshot feature, this is a really quick and easy way to take a snapshot of this. You can get the snapshot as a GeoTIFF, JPEG, PNG, or KMZ. So for these geo-referenced output options, you could use those as base layers, essentially, for GIS or for any other application that you're interested in. There's also web services that are available through so the underlying imagery service that provides that imagery. You can get those as web services, including WMTS, WMS, KML, and more. So I also have some documentation there if you're interested that provides some information on how to pull those layers into GIS. So finally here, we're going to export that data frame that we've created as a shapefile, and we can now see what that looks like in GIS. So I'm not going to really start doing any science on this here, but basically I've loaded up all of those layers and working in QGIS right now just to show you what all those layers look like. So just like we saw in Worldview, I threw that snapshot feature, I threw that GeoTIFF into GIS, so that's kind of what that base layer looks like. I could zoom in further and I can see that this layer that I'm kind of tracing with my cursor, that's the Mod 10A1 subsetted GeoTIFF that we received from the NSIDC API. Again, much coarser resolution over the Grand Mesa study site. I could zoom in even further, and I've pulled that clipped ASO high-resolution snow depth data set in, and you can see how high resolution this is. We actually see a road kind of coming through that, with the darker colors indicating lower snow depth values, and our SnowEx values as well plotted against this. So of course, you could do further analysis here, comparing the snow depth data across scales, looking at how the snow cover varies through time. But I'll pretty much leave it here. And to just sort of wrap up our demo for today, I do want to point out that there are a lot of other resources I didn't get a chance to cover in detail. I breezed through quite a lot of different features and tools that we have. We have other services, like for our MODIS data, for example, we have a data subscription service, which allows you to subscribe and receive data if they're ingested at NSIDC. Plenty of other materials. But I do want to mention we have a fantastic user services team at the NSIDC DAAC. If you have any questions in the future about our snow data, or any data for that matter, you can email us at nsidc@nsidc.org. That contact info is provided under the support tab of every dataset page. We have support buttons on all our pages as well. You can get to us there as well. So we can provide any other resources or answer any other additional questions you may have. So with that, I will hand it back over to Jennifer. We can move forward with questions and Q&A. Thank you.
All right. Thank you, Amy. So at this point, we will transition to an optional final set of polling questions. And we'll give these about 3 to 4 minutes or so. And then from there, we'll move directly to the Q&A period. I really appreciate all the feedback we've received so far. And I just wanted to note if there are any questions that we run out of time to answer within the framework of the question and answer period, we will ensure that the speakers get back to you offline. They will be provided with a log of the question and answer log, and so they should be able to follow up with you offline. All right, with that, let's give these a few minutes and then we'll transition to the Q&A. All right, thanks everybody. Okay, everybody, we're going to give this just a few more seconds and then we'll transition to the Q&A. All right, with that, let's go ahead and transition to the question and answer period. And if there's something that you think of afterward, I'll leave the virtual meeting space open. Please feel free to jot that into the Q&A pod. And so if you give me a moment to identify the first question, we actually had quite a few. Let me scroll to where that is available. Okay. One of our first questions was whether or not the SnowEx data is available in a NetCDF file format.
So that those data sets, and I know the snow pit data as well, those are all available in CSV.
So in CSV file format. Okay, thank you, Amy. All right, let me scroll down too. And then there was a question regarding, can I input the data to QGIS directly?
So yes, you certainly can, and depending on, I don't know what data in particular the person was interested in, but the geotiffs in particular obviously are very optimized for GIS analysis, and the CSV data as well. I know there's tools both with QGIS and ArcGIS as well that can kind of pull data in with as long as you kind of identify the XY variables. So yeah, so kind of depending on what you're interested in and what formats you're looking at, there's certainly those options as well. And even with the native HDF data, those can be pulled in directly as well.
Okay, thank you, Amy. All right. I do need to identify the next question. Okay. Some of these are actually, okay, is there any time to distribute this snow grain size data?
Snow grain size, again, I'm not sure what sort of mission they were interested in, or if they were asking about SnowEx in particular.
Yeah, so there was actually a question earlier on, I'm sure these two are related. Is it possible to retrieve snow grain size data from any NASA or ESA satellite? And Walt did provide information about an algorithm that has been developed at JPL. But if either one of you wanted to speak to this. So Walt,
this is
go ahead, Walt.
It's called ModSCAG, so it's a MODIS derived, and it gets snow cover fraction and then snow grain size. That's a research product. There's been papers published on it. We don't have the data at NSIDC, at the NSIDC DAAC currently. I think it may be available through JPL, or some part of it maybe, but I'm not sure exactly what the data access is on that. But it is an algorithm that I think could be useful to a lot of communities.
Yeah, and I'll also mention for SnowEx, for the 2020 campaign data, we should be receiving snow grain size data for those PIT data sets. So those should be available with the 2020 data.
Okay, thank you. All right, so the next question is, are there any chances for updating climatological time series or measures with 2012 plus years?
Yeah, I guess I can answer that. So, the measures projects are specifically funded. They're typically 5-year projects. Sometimes funding continues for those, but for that snow product, it's specifically, it hasn't been, it wasn't extended. So that data does end currently at 2012. There's no current plans that I know of to update that. I mean, that may happen in the future with future resources. I did mention there's what's called the NOAA IMS Interactive Snow and Ice Mapping System, which does provide regular maps of snow cover extent. So that's one thing that one could look at for more recent data. And then University of Rutgers creates some nice imagery from those as well. So it certainly would be nice to have that updated, but it depends on the principal investigators and the amount of effort that they can put into that and resources for doing that.
Okay, thank you, Walt. All right, so let's see here. What is the coverage extent for snow cover and SWE into Canada? So snow water equivalent, right?
Yeah, I mean the mode or the AMSR products, the passive microwave snow water equivalent products, those are global, basically, generally by hemisphere. So it does cover all of the snow-covered regions, including Canada. I noted the limitations there. I'll also mention currently for AMSR 2, we have noticed a data error in terms of some limited coverage, not an error of data, but some areas where data is not being recorded right now for AMSR 2, and that's being addressed. So right now I'd use caution with AMSR 2 products, but that should be fixed within the next, hopefully within the next couple weeks or so.
Okay, thank you, Walt. I'm trying to answer some of these questions in the pod so everyone will be able to see them. So pardon the delay. Okay, so the next question is, so MODIS data is available on Google Earth Engine. Will other snow data be available on GE in the future?
Yeah, I can speak to that. So yes, MODIS snow data is available in Google Earth Engine, and that's being ingested and delivered by Google with limited NASA DAAC involvement. So NASA and the DAACs can't ingest our data directly into Google Earth Engine's public data catalog, but we have provided some support to Google. So NSIDC DAAC, we're certainly understand that our user community is very interested in this capability and having additional data available in Google Earth Engine. So we're gathering additional information kind of on use cases for having data in Google Earth Engine. And we've also developed some sample code for using APIs to pull data from Google Earth Engine. So if people are interested in that, please reach out to NSIDC and we can get you more information on that.
Okay, thank you, Amy. The next question is, I am an ArcGIS Pro advocate. Just curious if everything is possible in the open source environment listed in the notebook.
Yeah, so I don't know if they're asking, what can be kind of tied in with ArcGIS Pro. I mean, certainly, so, I didn't actually demo this today, but I provided some resources. So like those imagery layers that are provided through the NASA Global Imagery Browse service, I know that those could be pulled in directly to ArcGIS Pro. And of course, obviously, any of those sort of data outputs that I showed today can be pulled in. So we do have those connections with our imagery layers. And I know that there's a lot of other sort of work that's been going on across the NASA DAACs as far as enabling more sort of data availability through ArcGIS catalogs, things like that. So sort of the resources that we provided today kind of can be utilized with both kind of Esri software as well as QGIS like I showed today. And then we also have those kind of open source and OGC layers in particular as well that can be pulled into kind of all different GIS platforms. So I don't know if I directly answered your question there, but certainly do provide resources that can be pulled into Pro.
Okay, thank you, Amy. All right, I'm just looking here. Regarding satellite images, is it possible that different levels of pollution affect the homogeneity of the data?
I can answer that. It's for the visible imagery, you're getting what the sensor is seeing at the top of the atmosphere. So certainly pollution aerosols can affect that. There are some corrections for aerosols and things like that to try to get a better surface signature, but there certainly is that possibility. Passive microwave, for example, is much less affected by atmospheric issues such as pollution, so that's probably not as much of an issue. But the snow products from MODIS and VIIRS, that there are quality flags in there in terms of atmospheric issues, clouds in particular, but also just overall data quality affected by pollution and other factors. And so that's certainly something to be aware of in terms of using the data, to be aware of the quality flags and pay attention to those in terms of how confident you can be in the retrievals.
Okay, thank you, Walt. So the next question is, let's see, more of a comment and a question that this particular user finds that there are still lacking resources about Python on the Jupyter Notebook platform. Are there any step-by-step recipes or descriptions for Python Jupyter? Hopefully I have interpreted this comment/question correctly. If not, please feel free to correct me in the Q&A pod.
Yeah, that's a great question. You know, there are plenty of kind of sort of guides on kind of the use of, you know, Project Jupyter in general, you know, so Jupyter notebooks and sort of the Jupyter Lab interface that I was working with today for just sort of getting familiar with kind of how Jupyter notebooks kind of can be worked and set up. The lab interface as well in particular, with kind of setting up different sort of components, like I mentioned, you know, other languages that can be supported. So there are kind of resources just directly through Jupyter that I encourage you to kind of take a look at. I don't know what in particular, sort of as far as sort of working with Python code in particular and pulling that into Jupyter, you know, essentially it's sort of, you know, it's a nice way to kind of provide text and images kind of in addition to, for this example, Python code. So just like you've, you know, already been working with Python maybe in a different IDE or, you know, directly through command line, you can kind of, you know, use that same code, put that into Jupyter and run it directly through a notebook. So I'd sort of need some, you know, a little more detail on kind of if there's any, you know, specific questions related to the usage, Python in particular, or the Jupyter notebook kind of interface. But if you have additional questions, yeah, definitely feel free to ask now or reach out to NSIDC.
All right, thank you, Amy. The next question is, how does the NSIDC DAAC data compare to SnowDAAC data?
Walt, I don't know if you can speak to the SnowDAAC in particular.
Yeah, SnowDAAC, I'm not as familiar with those, you know, that with SnowDAAC specifically. That's based, I believe, largely from ground stations, and so ours is more satellite-based. And so, you know, the differences in the collection and the coverage. I know the SnowDAAC data is, you know, good quality data set and useful. And I look at things as, you know, the more you can bring in different data products together, you can help better understand all of the data. So I think SnowDAAC is a valuable resource for snow information, and I think it's, you know, complementary to the resources that we have at NSIDC, at the NSIDC DAAC.
Yeah, thanks, Paul. I mean, you know, in general, you know, depending again on what other data sets you're interested in at NSIDC DAAC that Walt introduced, you know, there's some variability as far as, you know, resolution and coverage. I know SnowDAAC data are at 1 kilometer resolution, but I know that there are, you know, lots of snow parameters available through SnowDAAC, including SWE. So, and then the coverage, I believe, is, you know, just over North America. So that's, you know, a difference as well if you're interested in other regions of the world.
Okay, thank you, Amy and Walt. So we have another question which may require additional clarification from the participant. Have you compared this algorithm with hail formation in tropical areas? So I'm not sure which data product was being referred to here.
I'm sorry, can you ask that
one more
time, Jennifer?
Have you compared this algorithm with hail formation in tropical areas?
I don't think so. The snow products are focused on specifically snow properties and detecting snow properties, whereas hail is going to be somewhat different in terms of properties. I don't know of any studies that have looked at that. I mean, there certainly could be some commonality there, but the algorithms were developed, you know, for optimization for snow, not for hail, and so I don't know if there would be anything that would be worthwhile that could come out of hail from these products.
All right, thank you, Walt. See here. So, do you provide any daily snow fraction data at NSIDC DAAC?
I don't believe we do. There's the MODIS and VIIRS are, like I said, are snow cover, snow extent basically. And you depending on what your spatial scale you're looking at, you could certainly, if you're looking at a more broad scale, you can use the, for example, 500 meter to bin up into one or 2 kilometer, 5 kilometer, to get a fraction, from that. But the actual retrieval that we have is not a fraction in a given pixel. It's snow or no snow.
Okay, thank you, Walt. And next. Okay, so the next question is related to AMSR2 data. AMSR2, the JAXA data set, is directly from JAXA GCOM-W. I know JAXA G-Portal also provides AMSR2. Are these two identical or not?
They are not. They are. They use the same source data. It's both JAXA Level 1R input brightness temperatures, but NASA has its own suite of products and algorithms and processing. There's a lot of similarities between them, but they are different algorithms and have different inputs in terms of ancillary data and how they handle forests and lakes and so forth. So they are different products. There have been some intercomparisons between them. I mean, on a large scale, they're pretty similar, but getting down into the details, there are differences. It's a case where I think different groups doing different algorithms, I think, can be quite valuable in terms of some algorithms work better in some areas and others work better in different areas. So looking at multiple data sets and products from multiple algorithms can be beneficial. So I think that's worthwhile. They're both good products and have a lot of development and research behind them. So they're both quality products, but they are unique products and independent.
Okay, thank you, Walt. I just wanted to say there's only a couple minutes left in the Q&A period, and so it's unlikely we will get to all of these questions, but please rest assured that I will forward this log to our speakers, and they'll be able to follow up with you. The last question is, are there plans to expand IMS data to years prior to 2006? And this participant is referring to the 4-kilometer product.
Yeah.
I don't believe so. I mean, there are the earlier charts that go back to 1966. Those are weekly and lower resolution. But so yeah, I don't think there's going to be anything going back further in terms of a 4-kilometer product. The data resources have improved over time, so that's improved the resolution and the input source data has improved. So I don't know of any kind of plan for any kind of reanalysis to try to extend that 4-kilometer product any farther back in time.
Okay, well, we've got 1 more minute, so we could do one more question possibly. Is there any problem in changing from MODIS to VIIRS within the same time series data set?
So I would say, I mean, you definitely need to be cautious of those. They are, the algorithms are very similar, but I don't think they're exactly the same. There can certainly be some calibration differences in terms of the reflectivity values and so forth, as well as slightly different orbits, which may affect at the time of day of sampling. So if you're going to use those together, I would say it's important to intercompare them and understand biases between them. I do believe there's been some papers published by Paul and also Jeff Key is another one. Dorothy Hall at NASA Goddard, who's one of the primary principal investigators for the snow products. So you could search for those to look for understanding the differences between those products. But definitely, I would say it's important to, you don't want to just use those interchangeably, or you're going to get biases between the products.
Okay, thank you, Walt. Thanks, everybody. At this point, we have run out of time for questions, but again, I will forward the log to Walt Meyer and Amy Steiker, and they'll be able to follow up with you offline. We do appreciate your participation today, and we hope to see you at an upcoming webinar. Our next webinar will be held on June 11th, and we'll focus on cloud-based efforts at the NASA Global Hydrology Resource Center DAAC. And so be looking for details in the weeks to come on earthdata.nasa.gov. And if you're signed up to our webinar listserv, you'll receive an announcement for that as well. Thank you to our speakers. At this point, we will log off from the audio component, and I'll leave the virtual meeting space open an additional 10 minutes. If anyone's interested in adding additional comments or questions to the Q&A pod or downloading the presentation file for today. Again, thanks to our speakers and thanks to all of you. So with that, we will log off from the audio component, and I'll leave the virtual meeting space open. All right, thanks everybody. Goodbye now.
Thank you.
Thank you.